Hi there. Today we're going to look at limit laws. So these are just properties of limits. We've got our basic properties, which just say if we're looking at the limit of a constant b, then it's going to be that constant b. If we've got just a function that's just x, then if we're looking at the limit as x approaches c, it's just going to be c. And if we've got x to some power, then that's the same as saying the value c to that power. The ones that we're actually going to use, though, more frequently are below this. So the property of limits where we've got the scalar multiple. So this is where we're multiplying by a constant, the sum or difference, product, quotient, and power. So all of these are more popular, as is the limit of a composite function or composition function. So I'm just going to put a star here because these ones are important, and then a star here because this one is also important. So this one's interesting because it says that if we've got two functions, f of x and g of x, where if we look at the limit of x, the limit of f of x as x goes to c and say that's L, and then we look at the limit as our input goes to L of g of x, we're going to get g of L. So this means that the limit of a composition is the same as the composition of the limit, which is kind of weird to think about, but let's see how that works. So for this problem, we're going to look at, let's do the limit as x approaches 0 of g of f of x. All right. So breaking that down using what we have up here, let's see what we get. So we have the limit as x approaches 0 of f of x. So the first way I'm doing it is kind of the longhand way. And then the other way I'm going to do it is going to be using this property here. So the stuff in the box I'll do second. All right, so now I've done this first part, the f of x, and gotten that L. The second part says, well, if we look at the limit as x approaches L, so in this case 4, of g of x, we're going to get two. So we have two limits here, right? Two steps. Let's now condense that into one step. So this gets us to our final answer down here of 2. So now we're going to use this property. So I'm once again setting up the limit as x approaches 0 of my composition of functions. And that's the same as saying, well, I'm going to plug into g, whatever that limit x approaches c is, which is the same as saying g of L. So f of x is x squared plus 4. All right, we've already done this. When you plug in that 0, you're going to get and then we do g of 4, which is the square root of 4, or 2. All right, so all this does is it cuts out the second step where we write out all that limit notation. So it kind of gets us to the final result faster. So that's our composite property. Now let's look at the I-dos. So these are going to use the properties that we put a star next to. So we're given two limits as x approaches c for f of x and g of x here, those equaling 3 and 2 respectively. For this first one, we've got the limit as x approaches c is 5 times g of x. So our property says that's equal to 5 times the limit. So if we're going to be consistent with our rules, we'll call that k and l. So that would be 5 times k, 5 times 2, 10. This one says f plus g, so that would be the same as saying l plus k. All right, and the reason I'm using l and k is because that's the notation that the rules use on the previous page, so I'm just trying to be consistent with them. Product, l times k, 3 times 2. All right, so you'll see that these are pretty fast, almost mindless even. All right, so I just did 4 problems within the span of a few seconds. All right, and then for these, same idea. So we've got the cube root here. That's a power, so that's the same as saying, if I'm calling this L, the cube root of my limit L. So my limit here is 27. So the cube root of 27 is 3. Then I've got L over 18. 27 divided by 18. 9 goes into both, so we've got 3 and 2. Same idea here, we've got L squared, 27 squared, which is 129. And then we've got L to the 2/3. All right, so this fraction here, that's the same as saying the cube root of L. That denominator tells us the nth root, what that root is, and then the numerator is the exponent squared. So my rule of thumb is always make the number smaller first, because you can do that in your head and then make it larger. If we make it larger first by squaring it first, it's going to become unwieldy and we'll need a calculator. So the cube root of 27 we know is 3, and then square it 9. So I could do that easily. However, I did it in the other order, 27 squared, I get 729, and then the cube root of 729 is not something that people know offhand. All right, so make it smaller first and then bigger. Go ahead and give the we-dos a try and then watch the video to check your answers.